We are ready. As soon as I get on here. Well, I guess I could get rid of that obnoxious stuff up here. Yep, 5 days ago.
I had a guy call me from Marquette yesterday, and he was like trying to reach a number one different from mine. What was it?
Okay, your talking is done. I'm starting. Zip it. Okay, the one we're going to do together is number 13 from your book, so that you actually know how to do 14 when I assign it today. You don't need your book open because I'm going to show you. They're showing you a shaded region here. How many trials you're doing, the probability of success. It says write the binomial probability that represents the shaded region. So, how many successes are they looking at have happened out of their 16 trials here? Exactly how many? There's 5 successes in that bar, 6 successes, and 7 successes. So they're looking at the successes being greater than or equal to 5, but less than or equal to 7. So it's which bars are shaded, and remember the binomials are the whole numbers. So that's the first thing it asks us to do, is write the binomial probability represented by the shaded region. So, for the first thing, we are looking at the probability that 5 is less than or equal to x is less than or equal to 7. There's the binomial probability. It says, then write the normal probability. That's that correction for continuity thing. So, where is the shaded region starting? It's starting at 4.5. Where is it finishing at? 7.5. So we're going to correct each of those to 4.5 and 7.5. So the correction, 4.5, less than or equal to x, less than or equal to 7. You didn't even have to make your own graph on this one. Oh, it's only less than 7. God, I make that mistake all the time. Okay.
Do the less than or equal to, or just less than, or does this affect your...
No, it doesn't affect anything. That's why I never think about it, so I get them wrong. Okay, so we wrote the normal probability that approximates the shaded region. Find the value of each probability and compare the results. So it wants us to do the binomial one, and it wants us to do the normal one, and compare them at the end. So let's do the normal one first. That's the 3-step process. So we'll do the normal probability here. Then we'll practice the old binomial stuff. Okay, the first step is to check to see that your sample size is big enough. And in here, I'll just tell you what the N was 16 and the P was 40%. So what do I have to do for the check again from yesterday? See if you remember these steps without looking back. You had to multiply N times P. So that's 16 times 0.4. And what is that? $7.2? Oh, 6.4? 6.4. And then what's the other part of the check? 16 times 0.6, the probability of a failure. And that is 9.6. So are we good to go with the normal? Okay. The second step is to make the correction for continuity. We've already done that up here. So it's just that P 4.5 less than or equal to x less than 7.5. And the third step is to actually find the probabilities using NCDF. But what do I have to do before I can use NCDF? Find the z-scores. What am I finding the z-scores of? The 4.5 and the 7.5. So the z-score for 4.5. 4.5 minus, where's the mean at again? the 6.4. Remember, the n times p is the mean. So we already did that up here. This is the mean. Where do I get my standard deviation from? Square root of NPQ. So the n was 16. The p was given as 0.4. So what does that make the q? 6. Okay. And then we'll crank through that same thing with the 7.5. We get a couple people to do each one. 2 places for the z-score. Out 2 places. First one is what? Negative 0.17, you said?
Negative
9.7, you said. And we'll wait for verification.
Yeah.
Okay. How about the 7.5? Again? 0.56. Agree? I got one yes. Oh. Yes or no? It's Carmela. I may want to check her out.
Yeah.
Okay. All right. Now what?
NCDF.
NCDF. Guess what's the probability? Negative 0.97 to 0.56. I believe her this time. 5162. 5462. Okay. All right. So you remember the 3 steps from yesterday. Not too challenging. Now they want us to compare this. Remember, this was an approximate for the binomial. Let's go back to chapter 4, where we used the binom PDF and binom CDF. So that's part 2 here. The binomial probability. Remember, we had our binom PDF and our binom CDF. What did we feed the binom PDF? It was 3 values. N was first, the number of trials you were doing. P, the probability of a success, and then X, the number of successes. And the PDF would give you exactly that one probability. Okay, the binom CDF would be NPX. But what did the CDF do?
Probability of
A set. Where did that set start from?
0.
0 through whatever X you put in there. So it added the probabilities from X equals from 0 through and including X. Well, what probabilities do I want here? How many successes did I want? 5, or 6, or 7. I want 3 kind of right in the middle. I think the easiest way to do that would be to do the PDF 3 times and add it up. That'd probably be your best bet. So just all in one line, I would go binom PDF, 16 trials, 0.4 success with a 5. Add that to binom PDF, 16 trials, 0.4 with a 6. Added to binom PDF 16.47. Or we could have done a cumulative through 7 and then subtracted off everything through 3. 2 CDF subtracted. I think this one's easiest to see. And we'll compare how close these probabilities are coming out. Remember, the normal approximates the binomial. It doesn't get it exact.
We went through the second part here? Or?
Yeah, this is the second part.
Why are we deciding these?
Because that was my probability question. I was looking for 5 or 6 or 7 successes.
Okay. Why couldn't we just use what we just learned yesterday though?
We could. The question said compared the 2 answers. to see how close they actually are. Is the normal a good approximation for the binomial? What'd you get? 5, 4, 9, 5. That is a pretty good approximation for it. So they don't ever come out exact, but they should be very close. Okay, the last example, I just want to practice this binomial stuff to bring it back to the front of the brain. Okay, can I get rid of this one? It's not bad. Oh, I'd say less. I would say less. Okay, it is.
Could it fit into?
I think so. So example 2. Use the normal to approximate the binomial, if possible. If it's not possible, use the binomial stuff. I'm not going to write all that down. So this tells me, this one phrase here tells me, oh, that's that 3-step process I'm going to show her on the test. So there's lots of points in that problem. I'm not going to skip any of the 3 steps. Okay, what we know here. Did you know? Nope. This is one made up. 6% of Americans feel more patriotic today than decades ago. More patriotic. ... You will select 70 Americans. And ask them, do you feel more patriotic today than long ago? Or do you think it's more patriotic today than long ago? What is the probability that more than 10 say that they feel more patriotic? Are you ready? Okay, first step is what? The check. Check to see if the sample size is big enough to make this a normal distribution. What do I do to check it? 70 times 0.06. 4.2. Is that okay? No, not okay. We're not going to go on with the normal, but the directions said if you can't do it with the normal, then do it with the binomial stuff. So, stopping there, going back to binomial stuff. So the binomial PDF and CDF. So we're just going to put a couple of them in here just to refresh your memory. Let's do the more than 10. So the probability, what is more than 10? X is greater than 10. So how many successes am I actually looking for? Anywhere from 11 through, I'm only doing 70 trials. I want those probabilities added up. Would I want to do the binomial PDF here this many times and add them all up? Let's go CDF. So I don't want anywhere from 0 through 10. That's the chunk I want to subtract off. So, how do we use the CDF to give us this answer? 1 minus, because I don't want this bottom chunk. 1 minus binomial CDF.